Okay. So now we will study another example of an embedded system, that is a bar level liquid detector. This bar level liquid detector is used to estimate the fuel in a car. So for instance, let's assume we have a fuel tank in a car. So this is a fuel tank. And in this fuel tank, we can use a pressure sensor at the bottom of the fuel tank that will estimate the pressure on this sensor. So if this fuel tank is filled up to this point, so the pressure sensor will produce a smaller value, and if the fuel tank is half empty, it will produce a high value, and if it's full, it will produce the maximum value. So for this embedded system, so we are using a pressure sensor. So this is an analog data. We have to convert this data into a digital data using an A to D converter. An A to D converter will convert this analog data into a digital data. Let's assume that, and then before this A to D converter, there will be also some signal conditioning circuit. Signal conditioning. You have a pressure sensor now. It will pass through the signal conditioning circuitry. Then you use an A to D converter. Let's assume that this output of A to D converter is an 8-bit data. Then we will use a microcontroller. Microcontroller will process this data, and then we can use 8 LEDs, 3, 4, 5, 6, 7, 8. LED 1 up to LED 8. So if the fuel tank is half full, so it means 4 LEDs should be on. So if there are 8 LEDs, 1, 2, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. So there are 8 LEDs. So we can say that if the fuel tank is 12.5% full, only 1 LED should be on. That is LED 1. 1 LED should be on. If it is 25% full, that means it's 1 quarter. 2 LEDs should be on. And if it is 50% full, it means 4 LEDs should be on. And if it is 100% full, all LEDs should be on. So an input to this embedded system is a pressure sensor, and if we know that the pressure sensor generates an analog value, so let's assume that analog value that is generated after the signal conditioning. So now we can have a correspondence between the voltage and the count. So let's assume that the voltage ranges from 0 to 4 volt. So it means that if it is 1 volt, this implies that it is quarter full. If it is 2 volt, it means that it is half full, and if it is 4 volt, it means that it is 100% full. So now this is a linear graph. We assume that the relationship is linear between the voltage and count. So it means that if the voltage is 1 volt, the count So we are using an 8-bit signal. So the maximum value for an 8-bit signal will range from 0 to 255, because it will range from 0 to 2 to the power n minus 1. And in this particular example, n is 8 because we are using 8-bit data, so it will range from 0 to 2 to the power n minus 1, 0 to 2 to the power 8 minus 1, and it is equal to 255. So if it means if it is 1 volt, so we can divide this 256 into 8 intervals, and each interval represent a step of 32. So we can write a program for this system. So if we say that if the count value is less than 32, so all LEDs should be turned off. But if the count is between 31 to 63, if the count value ranges between 31 to 63, only one LED should be on and the remaining 7 LEDs will be off. So if the count is from 64 to 95, 2 LEDs should be on, and if the count is 255, that's the maximum value, so it means all LEDs should be turned on. So we have one-to-one correspondence. So if the voltage is 1 volt, the count will be equal to 64. If the voltage is 2 volt, so the count will be 128. If the voltage is 3 volt, the count will be 192, and if it reaches the maximum value, that is 4 volt, the count will be 255. So now we can see this. So let us assume that if we have a fuel tank, the fuel tank is like this. Level 1, 2, 3, 4, 5, 6, 7 and 8. So if it's 12.5% full or 25% full or 50% full or 75% full or 100% full, so the corresponding volt will be 0.5 volt and the count will be 32. The volt will be 1 volt at this point and the count will be 64. The volt here will be 1.5 and the count will be 96. The volt here will be 2 volt and the count will be 128, and for the final point, for the maximum value, the volt will be 4 volt and the count will be 255. So now we can write a program in C or assembly. So at this point, so we can have a C program, simple program, like if count is smaller than 32, count is smaller than 32, all LEDs are off. Else it means now the count is greater than 32, so we have to make a second check that if count is smaller than 63, one LED should be on. So it means if we have 8 LEDs, 1, 2, 3, 4, 5, 6, 7, 8, and if it is greater than this, only one LED should be on. And if it is at this point 1, 2, 3, 4, 5, 6, 7, 8, so 2 LEDs should be on. So we can say that else if count is smaller than 64 and 96, it means that is greater than 64, so 2 LEDs should be on. And in the final else, all LEDs are on. So this is another example of an embedded system. Hmm?